Amana S-Series Installation and Commissioning Technical Training Module, TRV 6.2. This material provides technical information that is only to be used by appropriately trained and certified HVAC/R installers and technicians who have agreed to the terms and conditions available here at https://www.daikincitib2btermsofuse.html. If you have not agreed to these terms and conditions, you may not use or view this material, and you assume responsibility for any injury or property, system, or equipment damage which may result. If you have agreed to these terms, you also agree by viewing or using this material that this material, by its nature, cannot include a discussion of everything necessary to effect a proper installation or repair of HVAC/R equipment, nor can it address every possible scenario or environment a technician or installer may encounter. Accordingly, this material should not be considered as recommendations for the best practices and will not be considered installation or repair instructions to the extent of any conflict with Daikin or Goodman issued manuals and specifications or industry standards and regulations. Each installer or technician remains fully responsible for any injury or property, system, or equipment damage which may result from your installation. Copyright 2023, Daikin Comfort Technologies North America, Inc. All rights reserved. Recording, copying, or distributing of this material is prohibited without written permission from Daikin. The following training does not include A2L connections, but still applies to installation and commissioning. This training will include pre-installation, installation, and commissioning. Let's start with pre-installation. Outdoor unit location considerations. Always follow the instruction manual for equipment clearances. Improper outdoor unit placement can cause adverse operation of the equipment, for example, short cycling, defrost, etc. Do not stack more than 2 outdoor units, with at least a 20-inch vertical clearance between the outdoor units. Sound vibration transmission should be considered when installing the outdoor unit. Ensure that the roof structure can support the weight of the outdoor unit. Refer to the specification sheet for the outdoor unit weight. Proper consideration should be given to the weathertight integrity of the roof. Electrical noise. The inverter units should be well grounded. This prevents the potential effect of electrical noise from the inverter to surrounding equipment. Keep enough distance from home stereos, personal computers, etc. At least 60 inches. Biflow filter dryer. A biflow filter dryer is shipped with the outdoor unit as a separate component. If the paint of the steel filter dryer has been burned or chipped, repaint or treat with a rust inhibitor. The recommended location of the filter dryer is before the expansion device at the indoor unit. Cold climate operation. Drain pan heater considerations. A drain pan heater is available when the unit is installed in a climate where the drain may freeze. It is highly recommended that you use a drain pan heater in areas where the outside temperature drops below 32 degrees Fahrenheit for more than 12 continuous hours. Do not use the outdoor unit drain pipe kit. If so, there is a risk of freezing. Only utilize the existing holes for drainage. Remove the rear inlet grill to prevent snow from accumulating on the rear fins. Installation. Refrigerant piping. Only install dryers, oil traps, or other line components in your piping work if instructed to do so in the installation manual. Use only refrigerant-grade, dehydrated and sealed copper tubing to connect the condensing unit to the indoor unit. Tubing should always be cut square, keeping ends round and free from burrs. Clean the tubing to prevent contamination. Inspect existing refrigerant lines and remove any section of the copper fittings with evidence of damage prior to installing a new unit. Damaged refrigerant lines and fittings will cause poor performance and harm the compressor. Amana does not approve the use of aftermarket accessories such as dye or stop leak. We have not tested these products and do not know the performance or the reliability of these products. Insulating refrigerant lines. The gas line must always be insulated between the indoor and the outdoor units to prevent condensation from forming. The liquid line must be insulated if more than 50 feet of liquid line will pass through an area that may reach temperatures 30 degrees Fahrenheit or higher than outdoor ambient temperature. Insulation must be installed in a manner which protects the tubing from damage and contamination. Insulation with 3/8-inch wall thickness is recommended. In severe conditions, hot, high humidity areas, 1/2-inch insulation may be required. Piping support. Tighten brackets so they hold pipes in place but still allow for expansion. If you're hanging a line set from a joist or rafter, use metal strapping or heavy nylon wire ties that are securely anchored. Applications longer than 80 feet. Refrigerant tubing is prone to transmit noise and vibration to adjoining surfaces. Use adequate vibration isolating hardware when mounting line sets to structural members. Existing refrigerant lines. Drain as much residual compressor oil from existing line sets and traps as possible. Pay close attention to low areas where oil may collect. If changing refrigerant or using existing line sets, you must flush the existing lines. Use a professional flushing agent to remove any excess oil or debris from the prior HVAC system. Note: legacy oil drainage and passive nitrogen flush are recommended. Refrigerant piping. When the outdoor unit is mounted above the indoor unit, maximum line set equivalent length is 125 feet, which includes pressure losses from any elbows, bends, etc. Even though the maximum equivalent line length is 125 feet, which includes any bends or fittings, the maximum actual line length is 100 feet. And the maximum vertical separation between the indoor and the outdoor unit is also 100 feet. When the outdoor unit is located below the indoor unit, it requires an inverted loop in the suction line near the connection to the indoor coil. This prevents liquid migration to the outdoor unit from the indoor unit. The top of the loop must be slightly higher than the top of the coil. Maximum equivalent line length, 125 feet, which includes pressure losses of any elbows, bends, etc. But the maximum actual line length is 100 feet. Maximum vertical separation in this case is 90 feet. Brazing. Preparation for brazing. Remove the Schrader cores from the service valves before brazing tubes to the valves. Use a brazing alloy of 2% minimum silver content, 15% is preferred, and do not use flux. Wrap valves in a wet rag or heat gel to prevent damage to the valve. If the biflow filter dryer paint is scratched or burned, corrosion may occur. Brazing with nitrogen. Dry nitrogen must be used during brazing to prevent oxidation formation. Step 1. Leave the opposite end of the tubing open so that the nitrogen can exit during brazing. Step 2. Set the nitrogen regulator to 20 psi to purge the line for 15 to 30 seconds. Step 3. Set your nitrogen regulator between 1.5 and 3 psig to sweep refrigerant lines while brazing. Pressure test. Nitrogen pressure test. The first step of the pressure test should be 150 psi of nitrogen and hold that pressure for a total of 3 minutes. After 3 minutes, increase the nitrogen pressure to 325 psi and hold for 5 minutes. Next, increase the nitrogen pressure to 450 psi and allow that to stay in for a minimum of 4 hours to ensure that there are no leaks. Next, perform a triple evacuation. Triple evacuation is the only way to ensure that your system is dry. Step 1. Evacuate the system to 4,000 microns and hold for 15 minutes. Step 2. Break the vacuum with dry nitrogen to a pressure of 2 to 3 psig and hold for 20 minutes. Step 3. Evacuate to 1,500 microns and hold for 20 minutes. Step 4. Break the vacuum with dry nitrogen to a pressure of 2 to 3 psig and hold for 20 minutes. Step 5. Evacuate below 500 microns and hold the vacuum for a minimum of 60 minutes. Note, when the evacuation is complete, use the last vacuum to pull in the additional refrigerant charge, calculated by line length if the line set is over 15 feet. System evacuation. Some vacuum pumps come with 3/8 or 1/2-inch hose connections on the pump. By connecting larger vacuum-rated hoses and removing the Schrader cores, evacuation will be faster and more complete. Attach a micron gauge to the port on the core remover. Again, remove the Schrader cores from the service valves before brazing tubes to the valves to prevent damage to the valves. Voltage separation requirements. Voltage separation is a requirement per UL 1995. The diagram on the right shows high voltage, which is shown in green, which is main power, compressor and fan power, power to the subboards, and power conditioners. Low voltage, represented in red, are all sensors, communication cables, including thermostat cable. Maintaining wire routing after servicing any inverter air conditioner is very important. Note, before contacting the inverter board, power the unit down and verify that the measurement between C positive and C negative is 50 volts DC or less. Here is the main printed circuit board for a 1.5 to 3 ton unit. This diagram shows the location of the solenoid coil if it's a heat pump, condenser fan, compressor UV and W terminals, outdoor electronic expansion valve, ambient thermistor, defrost and coil temperature thermistor, discharge, liquid, and suction thermistors. On the service PC board, here's the connection for the D checker, the DS1 and DS2 or dip switch 1 and 2, and the data connection. Smaller chassis, the 1.5 to 3 tons, use a heat sink behind the PC board. On the circuit board of the 3.5 to 5 ton unit, we show the location of the thermistor bank, data connections, dip switch 1 and dip switch 2, reversing valve solenoid, IGBTs or insulated gate bipolar transistors, which are surrounded by a DX cooling loop, the outdoor electronic expansion valve, D-checker port, 7-segment display and push buttons, compressor terminals UV and W, and the outdoor fan motor. Voltage monitor and surge protection. The use of a voltage monitor and surge protection device is highly recommended to protect the equipment from any voltage fluctuations or electrical surges. Warranty does not cover unit damage or failure of the unit starting up due to interruption or insufficient electrical service. The chart below shows the minimum and maximum and average voltage for the air handlers, gas furnaces, case coils, and the outdoor unit. High voltage wiring. Below is the minimum circuit ampacity and maximum overcurrent protection charts from the installation and operation manual. When using residual current operated circuit breakers, be sure to use a high-speed type 0.1 second or less 200 milliamp rated residual operating current. Use copper conductors only and insulated power wiring. Select the power supply cable type and size in accordance with the local codes. The unit rating plate shows a list of pertinent electrical data necessary for proper electrical service and overcurrent protection. Wires should be sized to limit the voltage drop to a maximum of 2% from the main breaker. Do not install the switch on the unit. Local codes often require a disconnect switch located near the unit. Note, 3.5 to 5 ton has an optional knockout to route the high voltage wiring. Route the power supply and ground wires through the high voltage port and terminate in accordance with the wiring diagram. Connect 208, 230 volt single phase field wiring to the terminal block located in the electrical panel. Below you will see the terminal block for the 1.5 to 3 ton and for the 3.5 to 5 ton units. Installing the Amana Smart Thermostat. Do not install the thermostat where it can be affected by drafts or dead spots behind doors or in corners, hot or cold air from ducts or ceiling fans, radiant heat from the sun or appliances, concealed pipes and chimneys, unheated and uncooled areas such as an outside wall. Mount the thermostat to be leveled, approximately 5 foot from the floor, on an interior wall using the included screws. Seal the hole made for wiring pass-through. Attach the thermostat to the top of the terminal plate and snap it into place. Low voltage wiring. Communicating wiring detail. If the low voltage requirements are not met, check or eliminate wiring connections, crossed wires, loose, bent or broken wires, etc. Replace the wiring. 18 gauge stranded is recommended. Move dip switch 1 switches on the outdoor printed circuit board to the opposite position. Low voltage wiring. Wiring detail when paired with an air handler. Minimum of 18 gauge wire. Maximum 125 feet between communicating thermostat and indoor units. Maximum of 250 feet between the outdoor unit and the indoor units. 4 wires from the indoor unit and coil printed circuit board to the thermostat. 2 wires to the outdoor unit. Wiring detail when paired with a gas furnace or modular air handler and case coil. Data line 1, which should be 18 gauge stranded cable, runs from the Amana thermostat to the case coil, to the gas furnace or modular air handler, and then to the outdoor unit. Data line 2 also runs from the Amana thermostat to the case coil, to the furnace or air handler, and then to the outdoor unit. Also should be 18 gauge stranded wire. The R wire connects from R on the thermostat to R on the control module to R on the furnace. And the C or common wire connects from the thermostat to the case coil and to the furnace. Between the furnace and the thermostat should be a maximum of 125 feet. between the furnace and the outdoor unit for communication lines can be 250 feet. The Cool Cloud HVAC app. The Amana Smart Thermostat must be used when setting up communication. Note, this system is not Comfort Bridge controlled. If wired to a Comfort Bridge furnace, the installer must check for critical OTA updates through the Cool Cloud app prior to commissioning. Do not energize the controller until you have verified critical OTA is complete. Connecting to equipment. Move to the proximity of the equipment, boot up the app, and the indoor equipment should appear on the device screen. Random Bluetooth equipment in range may also appear and can simply be ignored. If the equipment being searched for does not appear, choose Refresh in the upper right-hand corner. A unit may not show up if it is out of Bluetooth range, if another user is connected to the same Bluetooth device, or if the unit is not powered on. Tap the desired equipment to begin the connection steps. Pressing Logout returns the user to the previous login screen. Software updates. Once paired, available software updates will be displayed. Mandatory updates are required before moving forward. Optional updates can be downloaded or skipped. Pair device by code allows the user to enter the 3-digit code from the circuit board's 3 7-segment displays. Note, the user cannot pair the device using the Amana Smart Thermostat. Pairing to indoor equipment using the circuit board code. You will be prompted for the 3-digit access code shown on the 3 7-segment displays. If the code is visible, it can be entered in the code entry screen shown on the right. EWC UT3000 Zone Control. The UT3000 controls up to 3 zones using a single board. Up to 5 zones twinned using 24-volt power open and closed motorized dampers. The EWC zoning complies with Manual ZR, which is the ANSI or ACA 11 Manual ZR-2018. When paired with the EWC, you must set lockout temperatures from the UT3000 zone control board menus. You must set zone weights from the UT3000 zone control. Default settings are as follows. For a 3-zone, 70%, 15%, and 15%. For a 2-zone, 60%, 40%. Communicating thermostats in all zones. With the UT3000 zone control system, the zone panel will interpret the digital thermostat demands and stage or modulate the communicating HVAC system to meet the demands for each zone. Here you'll see the location of the supply air sensor, thermostat 1, damper number 1, thermostat 2, damper number 2, damper number 3, and thermostat number 3. Your 24-volt power input. This connection is for the Comfort Net air handler or furnace, the Comfort Net condensing unit or heat pump with an outdoor air temperature sensor connected. System commissioning. Commissioning can be completed on the Skyport Care app, and in many instances, it is preferred. Skyport Care is not covered in this training, TRV 6.1 through 6.4. Commissioning. The startup screen is displayed upon powering up the thermostat. The welcome screen displays preferences to choose from. The version of the thermostat is displayed on the Learn More screen. Selecting the setup options allows you to factory reset the thermostat. Begin Setup walks installers through the entire commissioning process to ensure that the system is configured properly and ready for the homeowner to use. It enables access to any setting. It remembers settings as they are entered. Individual may stop and restart as needed. The screens are populated based on the model numbers of the equipment matched to a database of device configuration settings. Full setup. Startup. Tapping Begin Setup starts the 5-step setup process. Communication, personalization, equipment setup, system optimization, and preferences. Note, all steps must be completed and reviewed before completing setup to ensure the system is configured properly and ready for the homeowner to use. For detailed menu settings, visit amana-hac.com. Step 1. Communication. Configures communication networks. Select Home Wi-Fi to search for networks. With Wi-Fi configured, the system can check the software version and update software to the latest version automatically. Note, a warning is generated if the router is not password protected. Step 2. Personalization. Tapping the Personalization tab allows you to edit default information. Personalization displays language, large font selection, date and time. If Wi-Fi is connected, date and time are set automatically. Thermostat name, and degree units. Step 3. Equipment setup. Displays equipment found by searching the communication network, or by adding or removing equipment and accessories from the preset list. The unit that is identified determines the list of configurations that will be displayed. View unit specifications. You can configure cool settings, heat settings, heat pump settings, humidifier relay, and heater kit. Cool settings. Cool airflow trim. Airflow may be adjusted from -15% to +30%. Adjusting your intermediate and low airflow trim settings lower can improve dehumidification. If you're planning to adjust the airflow trim settings, verify duct system and airflow requirements before adjusting these settings. Refer to the Installation Operation Manual for restricted airflow combinations. Cool profile. The system offers several custom on and off ramping profiles for cooling. These profiles may be used to enhance cooling performance and increase comfort levels. Cool airflow profiles. Refer to the Installation Manual. There are 4 cooling airflow profiles available. All residential inverter systems are factory set to Profile D. Profile D, which is default, ramps up to 50% of the demand for 1/2 minute. Then it ramps up to 82% of the full cooling demand airflow and operates there for approximately 7.5 minutes. The motor then ramps up to full demand airflow. Profile D has a 1/2 minute at 50% airflow off delay. Cool settings. Dehumidification. The thermostat reads the indoor humidity level. Target humidity set point is adjusted once the setup has been completed. The thermostat controls the humidity level of the conditioned space by using the cooling system. Dehumidification is engaged whenever the cooling demand is present and humidity levels are above the target level. The circulating fan output is reduced. The system runtime increases. Dehumidification demand is controlled based on humidity differential between set point and detected humidity level. If the room temperature is 2 degrees Fahrenheit higher than the set temperature, dehumidification demand will set the priority to room temperature control. Dehumidification performance. The performance can be improved by changing the dehumidification profile in the Amana Smart Thermostat to A, B, or C. The setting can be changed from the dehumidification setting menu at any time when required. The minimum compressor speed will be locked depending on the selected profile. The operating range limitation will be unlocked when the humidity reaches the set value. There must be a call for cooling and a demand for dehumidification. Heat settings. Heat airflow trim. A user can change the airflow trim at high, intermediate, and low compressor speed. Airflow may be adjusted from -15% to +15%. Refer to the installation operation manual for restricted airflow combinations. Note, lower heating speeds will reduce electrical consumption, lower operating sound levels of the blower, and increase the outlet air temperature delivered to the home. Heat settings for heat pumps. Defrost heat. You can select the outdoor temperature for backup heat to activate during defrost, at or below 30 degrees Fahrenheit to 65 degrees Fahrenheit, or on or off. Defrost interval. Every 30, 60, 90, or 120 minutes is selected from the thermostat menu. If the defrost sensor drops below the freezing temp during the selected interval, the outdoor unit printed circuit board initiates a defrost cycle. The outdoor fan motor and compressor will de-energize. The reversing valve switches from heating to cooling operation. The outdoor circuit board communicates to energize backup heat if it's enabled. The coil and defrost sensor temperatures are monitored every 5 seconds. When the coil temperature reaches 54 degrees Fahrenheit and the defrost sensor temperature is greater than 43 degrees Fahrenheit for 30 seconds, the defrost operation is terminated. Defrost operation. Intelligent defrost. If it takes longer than 5 minutes to reach the target coil temperature during a defrost cycle, then the initial time interval you selected will be shortened for entering the next defrost mode. If it takes less than 5 minutes during the defrost mode to reach the target coil temperature, then it will lengthen the interval before entering the next defrost mode. Heat pump settings. On a dual fuel system, changeover between heat pump and gas furnace is determined by the balance point temperature. The heat pump will turn on above the lockout temperature. The gas furnace will turn on below the lockout temperature. If your balance point was set to 50 degrees Fahrenheit, above 50 degrees Fahrenheit, the heat pump would operate. Below 50 degrees Fahrenheit, the gas furnace would operate. The auxiliary electric heat strip and backup gas heat will engage above lockout temperature in the following conditions. If the space temperature falls approximately 4 degrees below set point, or if there is a demand of between 110% and 200% from the system. Bad equipment. The Amana Smart Thermostat is compatible with multiple accessories, such as auxiliary heat source, humidifier, dehumidifier. You can install auxiliary heat source, humidifier, and dehumidifier by using auxiliary and auxiliary C terminals. Recommended using an isolation relay between auxiliary device and the thermostat. UV bulb, electronic air filter, HEPA filter, EWC zone board, and a 24-volt gateway. Auxiliary heat source. On an Amana Smart Thermostat, selecting Add Equipment will allow you to configure an auxiliary heat source. This is not for setup of heater kit for backup electric heat. Your examples of auxiliary heat would be boilers, duct heater, boiler with hot water coil. Auxiliary heat is the only control option for a cooling-only outdoor unit. Auxiliary heat setup. Secondary heat settings. The control will allow you to adjust settings such as lockout and secondary heat activation temperature. Emergency heat mode will appear as a system mode when connected to heat pump units and can be used to directly turn on auxiliary heat source if enabled. T-on, T-off control. T-on and T-off provide an alternative control method to having the main AC or heat pump control the auxiliary heat source using its pulse input control algorithm. T-on and T-off is the only control option for auxiliary heat with cooling-only outdoor units. If the indoor unit is a gas furnace, or if it is an air handler with a heater strip, these heat sources will be controlled around the heat set point by the demand-based PI control algorithm. When T-on and T-off is selected, the auxiliary heat source will be controlled independently using these settings. Auxiliary heat control. When the heat pump is a primary heat source, the heat pump lockout temperatures are adjustable from -20 degrees to 65 degrees Fahrenheit in 5 degree Fahrenheit increments. Default is 15 degrees Fahrenheit. Auxiliary heat lockout temperatures are adjustable from -10 degrees to 75 degrees Fahrenheit in 5 degree increments. Default is 50 degrees. Auxiliary heat demand. T-on differential is adjustable from -7 to -3 degrees Fahrenheit in 1 degree increments. Default -3. T-off differential is adjustable from -4 degrees to 1 degree Fahrenheit in 1 degree increments. Default is 1 degree. When auxiliary heat is the primary heat source, the heat pump lockout temperatures are adjustable from -20 degrees to 65 degrees Fahrenheit in 5 degree increments. Default is 15 degrees. Set point differential can be set at -9, -7, -4, and -2 degrees Fahrenheit. Default is -2 degrees. Heat pump demand. T-on differential can be set at -1 or -2 degrees Fahrenheit. Default is -1. T-off differential is fixed at 1 degree Fahrenheit. Add equipment. Humidifiers. If the control is set to on with heat, it will activate the humidifier every time there is a call for heat. If the control is set to on with heat and humidity, it will activate the humidifier every time there is a call for heat and humidity. If the control is set to on with humidity, it will activate the humidifier anytime there is a call for humidity. Note: approximate delay of 3 minutes. On the setting of call with humidity, the call for humidity will activate at 3% below the humidity set point and will deactivate at humidity set point. Humidifier relay. On an AHVE air handler, for the setup for humidification functionality, the accessory terminals have 3 operational modes. 1. On, which means the humidifier is enabled during a call for heat. So during a call for heat, the accessory relay will close if there is an active call for humidification from the thermostat. 2. Off. Humidifier remains off, the relay is open. 3. Independent. The humidifier will cycle with any active call for humidification from the thermostat, independent of a call for heat. The relay is open during a cooling operation. This allows the user to select one of 4 fan speeds, 25, 50, 75, and 100%. The fan speed is used when the system is in an idle state and a call for humidification is made by the thermostat. Heater kit. It is important to set the capacity of the electric heater at two locations: the thermostat and the dip switch bank 3, dip switches 9, 10, 11, and 12 of the air handler printed circuit board. Auxiliary alarm. On AHVE air handlers, the control is equipped with two auxiliary alarm terminals. Alarm terminals TB4 and TB5 are typically utilized in series with a condensate switch, but could also be used with a compatible CO2 sensor or fire alarm. The auxiliary switch is normally closed. The connections open when an alarm occurs. Errors will be maintained in the equipment's fault history. Auxiliary switch part number 2P651240-1. On gas furnaces, the control is equipped with a 24-volt AC auxiliary alarm to be used for a condensate switch install designated by condensate in-out on the control. By default, the connected auxiliary switch is normally closed and opens when the water level in the evaporator coil pan reaches an undesirable level. If the auxiliary switch is detected to be in the closed position for 30 seconds, normal operation resumes, and the error message is no longer displayed. System optimization. System test. Running system test is required for the inverter units before proceeding to complete setup. The thermostat must be calibrated. The test needs to be completed without any errors. When the tests are completed, the run test screen is displayed. System test is complete only when the display code E11 notice clears from the 7-segment display on the heat pump or air conditioner. System must be in the off mode while running the test for the E11 code to clear. Charge mode. Selecting charge mode allows for a steady system operation to allow for refrigerant charging of the system via the suction charge port. The system will stop when Stop Test button is pressed or once the test is complete. Note: for proper charging of the system, please see the equipment's installation manual. Verify refrigerant charge. Subcooling. If the ambient temperature is between 65 and 105 degrees Fahrenheit and the unit is operating in 100% capacity, add refrigerant per the chart as shown. If the outdoor ambient temperature is less than 65 or greater than 105 Fahrenheit, weigh in the charge. Note: subcooling value is only valid while unit is operating in 100% of compressor speed in charge mode. Subcooling value displays on the 7-segment display only during the charge mode. System optimization. Error history. The error history menu stores errors from the most recent to the least recent. 10 thermostat and 10 equipment error codes can be stored. Each error includes an error code. A timestamp along with the equipment type that generated the error and a brief error description is displayed. Status screen. Status. The status menu displays data pertaining to the selected equipment. The scrollable list can be accessed any time by returning to the Installer Setup screen. Deadband overcool. The overcool value is overlaid on the deadband, increasing the range to maintain the minimum cool heat differential of at least 2 degrees. Boost mode. Boost mode allows the compressor to operate to a higher RPS or revolutions per second than factory maximum. Maximum RPS value is hard-coded into the software and cannot be changed. Cooling boost mode outdoor activation temperature can be adjusted in the boost mode menu. Boost mode will operate after the ambient temperature increases beyond the selected activation temperature and the compressor has achieved its maximum revolutions per second. Heat boost mode is enabled and disabled by selecting On/Off. On Amana Smart thermostats, you may select the maximum RPS offset. This allows you to adjust plus 10% RPS from the factory maximum RPS. Checking duct static. Refer to the unit rating plate for the maximum external static pressure, or ESP. Incorrect external static pressure may cause excessive temperature rise, motor stress, duct stress, reduced performance, unwanted condensation, etc. The positive static pressure is measured for a furnace at the supply outlet and must be read between the furnace and the cooling coil. On an air handler and MBVC at the supply outlet. The negative static is measured on a furnace at the plenum and must be read between the furnace and the filter. On an air handler at the return plenum and must be read between the air handler and the filter. On an MBVC, between the modular blower and the cased coil. Caution: when making the penetrations for your test probes, be careful not to damage the components within the cased coil. Static pressure, gas furnace, and AC coil. The design static of most furnaces is 1/2 inch water column. Use a manometer to measure the static pressure of the furnace only. Supply side is measured between the heat exchanger and the evaporator coil. The return side is measured between the blower wheel and the filter. Static pressure single-piece air handler. On a single-piece air handler, the evaporator coil has been installed at the factory and is already considered in the static pressure calculation. Use a manometer to measure the static pressure of the air handler only. Measure static pressure of the supply duct at the outlet of the air handler. Measure the static pressure of the return duct at the duct inlet of the air handler. Static pressure, two-piece air handler. On a two-piece air handler, the evaporator coil is not part of the air handler, so it must not be considered in calculating the static pressure. Use a manometer to measure the static pressure of the air handler's blower assembly only. Measure the static pressure of the supply duct at the outlet of the unit. Measure the static pressure between the outlet of the evaporator coil and the inlet of the air handler. Here's an example of a startup checklist for an Amana S-Series unitary inverter system. Pre-startup. Verify all packaging material has been removed. Remove all shipping brackets per installation instructions. Verify the job site voltage agrees with the unit serial plate. Verify condensate connection is installed per installation instructions. Verify proper clearance around the unit for safety, service, maintenance, and proper unit operation. Verify proper waterproofing of all ductwork, roof curbs, and electrical connections. Check line set for leaks. Verify gas pressure to the unit is within the range specified on the serial plate. Check to ensure that all fan blades and wheels are secure. Check refrigerant piping for rubbing and leaks. Repair if necessary. Check unit wiring to ensure that it is not in contact with refrigeration piping or sharp metal edges. Check all electrical connections and terminals. Tighten if needed. Verify that the outdoor unit has been energized for at least 2 hours before starting the system. Verify all accessories are installed and operating correctly. Check filters and replace if necessary. Verify the installation of the thermostat. An Amana approved communicating thermostat is the only approved thermostat for the unitary inverter unit. Dealer Edit. Navigating to Dealer Edit will allow you to access or revisit the installer setup screen. Dealer Navigation. Acknowledging the prompt enables you to tap the Learn More icon. The icon displays the installer code, giving you access to the installer setup screens. Thank you for joining us for the Amana S-Series Installation and Commissioning Technical Training Module, TRV 6.2. We hope you found this information helpful. Please continue to TRV 6.3, Cased Coils.